Okay, in this video, I'm going to talk about the mechanics that you need to show for a one proportion z interval from chapter 19. And I just want to show you both scenarios, one where you're given the number of successes as an integer value and one where you're given a percentage. So I'm going to use the two questions that I referenced in the previous video. So on page 449, number 29, we have the deer ticks. 32 of the deers have ticks out of 153 total. So when I'm calculating my mechanics here, what I'm going to do is I'm going to take my p hat, which is going to be the 32 divided by 153 plus or minus my margin of error, and I'm doing 90% confidence. So I have a critical value of 1.645 times my standard error. And because I already have a fraction, I'm not going to bother converting these to decimals. So p hat is going to be 32 divided by 153 times q hat, which is going to be 121 divided by 153 over my sample size of 153. Okay, now we're going to take a look at just plugging that into the calculator here. So let's take a look at that. Okay, we're going to go to stat, tests, down to choice A, one proportion z interval. So number of successes, that needs to be an integer value. So we're talking about, let me make this a little bit bigger. There we go. Okay. So here we have number of successes. Now that's a little bit too big. Let's try that again. Okay. So your number of successes in this is 32. 32 deer have ticks. Your sample size is that 153. And your confidence level is 0.9 or 90. Just keeping in mind this number of successes here, this 32, that has to be an integer, otherwise you're going to get an error, and I'll show you that in the next example. Calculate. So we have 0.155 to 0.263. So let's bring that over here. So our confidence interval is 0.155 to 0.263. And I would expect that you write out all the decimals here. So what I mean by that is the 0.07 and the, why don't I write those in? 0.07 and 23, so 0.07. Let's erase this. And 20, let's try that again. There we go, 23. Okay, so that's all I need to see for mechanics. You're just substituting into the formula here and then plugging it in the calculator to get your actual confidence interval. Okay, so let's take a look at another example now. All right, so going back to page 448, question 26, the difference in this question, as I addressed in my last video, is now they give you a percentage, not an integer value for the number of successes. So just looking at the retention rates for students enrolled in public college, our p hat is 0.719. So we have 0.719 plus or minus our margin of error. And now we're doing a 95% confidence interval. So this is going to be wider than a 90% confidence interval would be because our critical z value is larger. In the previous example, it was 1.645. So we have 1.96 for our critical z value times our standard error, and we're using standard error again because we don't know p as opposed to standard deviation. So we have p hat 0.719 times q hat, which is 0.281, divided by our sample size here, which is 505. Okay, so again, we're going to go back to the calculator here. We're going to take a look at this. We're going to go back to stat, test. I'll show it to you this time. The shortcut is to hit alpha and then A, or you can scroll all the way down to A. Okay, so one proportion z interval, our number of successes. So now I have my sample size 505 times my p hat, which is 0.719. Okay, Now you'll notice there that's not an integer value, and that's going to create a problem, but I just want to show you what you're going to see. Your sample size is 505, and your confidence level in this example was 95% or 0.95. Go ahead and hit calculate. Okay, so there you see your error domain. Anytime you get that, you need to realize why you're getting that. That's because we didn't put in an integer value for our number of successes. So, clearing out of there, going back to stat test, alpha A. All right, so I'm just going to change this to the nearest integer, which in this case is going to be 363. And I'm going to go ahead and calculate this confidence interval now, and I won't get an error. So we have 0.6796. So 0.6796 to 0.75802. Okay, so again, that's all that I need to see for the mechanics. One other thing I wanted to talk about in this video is some of the questions that you saw today, especially with the teens in the car accidents. Like in 13D, it said this guy claims in one of every five auto accidents, a teenager is behind the wheel. So what they're going to ask you to do is make a conclusion based on your confidence interval. So for this question, if there's a claim that the retention rate for students at a public college is at least 60%, well, does our confidence interval contradict that or support that? Well, if my claim is that it's 60%, at least 60%, my confidence interval supports that because the entire confidence interval lies above 0.6. Now, if they said it's at least 70%, then my confidence interval does not support that claim because 0.7 lies right between my interval. So some of my interval falls above 70%, some falls below 70%. I can't validate that claim. So we'll talk about this more on class later in the week.